Hi, so this video is about our capstone project, which is entitled Finding the Roots of Nonlinear Single Equation Using Bisection Method. So for this project, we had made use of GNU OCTAVE, which is software featuring a high-level programming language primarily intended for numerical computation as well as solving linear and nonlinear problems. Utilizing GNU OCTAVE, we had devised an algorithm that would follow the bisection method, wherein the root is found by repeated bisection of an interval to which preceding iterations would be continuing from the half where a sign change occurs. Notice in the algorithm that it asks the user to input four things. First would be the nonlinear equation. Next two would be the two guesses for the bounds of the interval that would be later used on the bisection method. Fourth would be the tolerance. Next step would be the functional value. So next step would be determining the functional value of the assumptions in regards to the initialized equation. First step, sign check would be represented in this line. So the slide check is a way for us to determine whether the bounds or the bounds for the interval contains the root. Next would be the bisection. So this bisection happens as to determine where the location of the root is at, whether it be in the first half or in the second half. Third would be redefinition of the interval. So the redefinition of the interval is a way for us to shorten the bounds, thus specifying more the location of the root. And then repetition until, fourth step would be the repetition until the root is found, which is observed here. So uh, with repeated bisections, imagine a graph, the curve of the equation would, with the interval, the y values would approach 0 and the x will approach the root. And then output would be the root. Let's try an example. First guess, let's try 0, 1, tolerance would be that. And the root for this equation would be 0.585785. Let's try the same equation with a different guess, with a different bound. Let's go for the function for the program, input. Second guess would be this. Result would be 3.414215. Good. Let's try a different function. So for this particular function, the root would be 0.517757. So that's about it.